Good morning. Welcome to our webinar SEW-1. This is the first in the series of SEW webinar. We will be discussing about the SEW problem. SEW stands for Stator End WindingSEWvibration. And it is a problem that has been affecting the power gen industry for over 50 years. So what you will hear today is about where this SEW vibration comes from and about it, and that it has tremendous impact on the life of your generator. The problem, as I discussed before, it is a sudden fire. And the pictures shown here from the end winding of a small hydro power plant in India owned by the Tata Group. Actually, they are our first customer. 5 years ago, they had an accident and the end winding was burnt. The cover is on. They didn't even realize it and keep on operating it until 1/4 of all the end windings were completely damaged. And with that, they will never wish it to happen again. They call us, and then we have installed the solutions. Now, this picture is an act. They appreciate what we did, and the plant manager got to me, my friend, and he said, show this picture to the world, because not realize how important SEW is. And now they will see. Now, of course, there are less cases of burnt end winding, but nevertheless, you can make the generator stop working. And this is an example of also a small hydro generator. And if you take a closer look, you will see the insulation has been damaged, and the generator will stop functioning. So why are we here talking about it? Because we have invented a technology that we think is most suitable to solve this problem. And this technology is called fiber black grating. And to start, 20 years ago, QPS invented the face mask. This face mask, by the way, it is a tooling that allows people to manufacture fiber black grating in volume. Fiber black grating is like the equivalent of a transistor. It's the basic building block. You know, the invention of the transistor given rise to all kinds of innovations today, including our PC and I think eventually the smart grid program as well. So we became the first to pioneer on this fiber black grating technology, and then eventually we accomplished volume production and have been involved very deeply in the telecom industry. The quantity we produce come up to 8,000 to 10,000 a month. Now, in order to supply to the telecom customer, you have to be certified by Telcordia. Telcordia is a set of rigorous programs that prove the reliability of your technology and your products. And for example, their criteria is devices have to be proven to work for 25 years. What an amazing match to what we need for generator. Generators are at least expected to run. So if you have sensors that can last just as long, then it is matching very nicely. So in 2006, Peter Kang has decided to take the technology platform of all developed for the telecom industry and then adapt it for the power industry. And we invented a structure called fiber. It is a device that can monitor both vibration and temperature. Problem of SEW. Now, before I do that, I mentioned a few attributes why we find this FVG very appropriate to solve this stator end winding problem. First of all, it is very small, just like a human hair, and therefore extremely light in weight. And as I mentioned before, Telcordia forced us to qualify for long operating life, something that minimum of 25 years. And so it is a technology already proven by use, first by the qualification and then the continuing use of the fiber grating in the telecom industry. And by the way, and this is the technology that enable the telephone calls to come down in such a low price that we enjoy intercontinental calls with a fraction of a few pennies. Another thing I should point out is the fiber grating itself. Once it's made into a sensor, it draws no power. In fact, no conducting part, nothing metallic. And since it's made with glass, it is completely immune to electromagnetic field or RF. So, and finally, you might find inside the generator where the temperature can be high as well as having high voltages. So again, fiber grating, it is to meet this challenge. What we like to achieve today is to show you the SEW problem and then in general discuss one of the main failure mechanisms of the generator. And then elaborate on the stator end winding. What is it? Where does it come from? What can we do about it? What are our options? Now, you might want to ask a question, say, can we eliminate this or reduce this? Okay, yes. We said vibration is most pronounced at the end winding. And so I want to explain to you a little bit why is it occurring there. In a generator, the winding sticks out on both ends, make a loop, and then come back to the main body. And in very large generators, the end winding can be quite. And in fact, in early days, most manufacturers are not aware of this problem. So they did not pay a lot of attention to reinforce the mechanical support of the end winding. And as a matter of fact, the end winding is like a mechanical amplifier. And if the body of the stator vibrates, then the end winding will be vibrating even more, maybe at 5 to 10 times the amplitude. The only good thing about that is you got a free space enough to mount your sensor there to make it easier to monitor this phenomenon. Now, what happens if the amplitude become large, rubbing will start between the windings. And the rubbing will physically ablate and create damage in the semiconducting paint. And then with the mica layer exposed down below, it continues to rub and then make the material thinner and thinner, and then eventually it lost its electrical insulation properties. And now next point I want to develop is that this vibration is actually a good way to monitor looseness inside your machine. Now, many of you wish this vibration doesn't exist. I'm afraid I have to disappoint you. This vibration comes from the very structure of all rotating machine. And in such a structure, you have a turning part which we call rotor, and another stationary part called the stator. Now, since nobody makes perfect things, the rotor is never perfectly centered or aligned. So as the rotor turns, sometimes we get closer to the stator and enabling electromagnetic forces interactions much stronger than otherwise. Now, at certain times, they also become further apart. Again, it reduces the electromagnetic forces. Remember that the rotor and the stator structure are very large and heavy, but these forces are so strong that it sets up a vibration pattern. Okay, this vibration is further aggravated if you have a rotor structure that is not perfectly circular. And if you have a local protrusion in the rotor, it always also gives rise to this SEW vibration signal. And signal is electrical in nature, and it is always 2 times line frequency. Why is it? Okay, I got a picture, some sort of animation scheme to show you why the 2 times line frequency arises. In most of the generator, we are talking about a 2-pole design. And every time when it turns,